Hello there, Mr. Sutton here, bringing you the AB Calculus 312 Extra Practice Number 1 solutions on derivatives of inverse trigonometric functions. To find the derivative of arctan of 3x, I need to take the derivative of the outer function, so arctan of something. That's going to be 1 over 1 plus something squared, so 1 plus a 3x quantity squared, times we have the derivative of 3x, which is 3. And I could leave it like this unsimplified, or if I want to simplify it, I could write this as 3 over 9x squared plus 1. Either way, to take the derivative of this one, I need to use the chain rule. So I have the square root of something, which is really just arcsine of x to the 1/2 power. Derivative of that would be 1/2 of 1/2 times arcsine to the negative 1/2. And then we have to multiply by the derivative of arcsine itself. And that's arcsine of x. We don't want to lose our variable. So that's going to be 1 over the square root of 1 minus x squared. And we're done. For this problem, derivative of arcsine of x cubed, we're going to start by taking the derivative of arcsine of something using our chain rule here. So that's 1 over the square root of 1 minus something squared, so x cubed squared, times our derivative of x cubed, so that's 3x squared we're multiplying by. And if I wanted to simplify this, I could write this as 3x squared over square root of 1 minus x to the 6th. For this problem, we're trying to take the derivative of this crazy expression. So we're going to use the chain rule, starting with our outer function, which is something to the 5th power. We've got 5 times this big something here to the 4th. Now we have to multiply by the derivative of arccotan of something. So that's going to be negative 1 over the something squared plus 1, so x to the 9th squared plus 1. Now we have to multiply by the derivative of x to the 9th, the innermost function. That's 9x to the 8th, and we're done with this. For this problem, we're trying to take the derivative of this expression. Using our chain rule, we start by taking the derivative of arccosine of something. So this is going to be negative 1 over the square root of 1 minus something, this square root here, squared. Next, we have to take the derivative of the square root of negative x to the 3rd minus 4. So that's going to be 1/2 times negative 9x to the 3rd minus 4 to the negative 1/2. And then finally, we have to take the derivative of negative 9x cubed minus 4 itself. So that's going to be, using our power rule, negative 27x squared. And then we're done. On this problem, I'm trying to take the derivative of arcsine of all this craziness. Using our chain rule, let's start by taking the derivative of the outer function, arcsine of something. So that's going to be 1 over the square root of 1 minus something squared. So this radical is being squared in here inside another radical. Looks pretty crazy, but we're not going to simplify. Let's multiply now by the derivative of this square root. So that's really going to be 1/2 times all the stuff inside to the negative 1/2. And finally, we have derivative of 6x to the 4th minus 5, which is 24x to the 3rd. On this problem, we're trying to evaluate the derivative of sine inverse, or arcsine, of x at x equals 1/2. So let's first find the general derivative of inverse sine of x. That's going to be 1 over the square root of 1 minus x squared. And all I have to do now to take this derivative is just plug in 1/2 for the x. So that's going to be 1 over the square root of 1 minus 1/2 squared. And I could simplify this further, but looking at my answer choices, it looks like they're giving me this exact thing in answer choice B. So I'll just pick that. On this free response problem, we're given a table with values of f and its derivative, and we're also given that g is this function f of x squared over e to the x. For part A, we want to find g prime of negative 1. All right, well, for that, I'm going to use the quotient rule. So that's going to be u prime v minus uv prime over v squared. And let me use the box and ribbon to help me with this. So my numerator, I've got f of x squared. Denominator is e to the x. And now their derivatives. For f of x squared, I need the chain rule. So that's going to be f prime of x squared times the derivative of x squared, which is 2x. And the derivative of e to the x is also e to the x. At this point, I need to plug negative 1 into all this. I mean, I guess I could multiply this out and plug it in and then plug in negative 1, but I'm just going to plug in negative 1 to the parts and then just build it from what I've got with negative 1 here. So plugging negative 1 into each part of the box here, I've got f of x squared with negative 1 plugged in. That's really going to be just f of positive 1, which if I look that up in the table, that ends up being 2/3. Next, I've got e to the negative 1. That's really 1 over e. Down here, this is going to be f prime of positive 1 times 2 times negative 1, so negative 2. F prime of positive 1, that's 4/3, multiplied by negative 2 is negative 8/3. And then here, this is the same as the upper right here. We still have 1 over e because we have e to the negative 1. All right, now I'm going to multiply this out using the ribbon. I've got u prime v, that's going to be negative 8/3 times 1 over e, or negative 8 over 3e. I'll just simplify as I go here. And then coming the other way on the ribbon, I've got minus 2/3 times 1 over e. So that's going to be minus 2 over 3e. And then down below, I've got v squared. So that's 1 over e squared. Simplifying a little bit in the numerator, these are actually the same denominator, so I can combine these into negative 10 over 3e. And down here, I've got 1 over e squared. Well, I can go a little further if I really want to simplify this. Honestly, I could have stopped here, but I just love simplifying, and I'm not actually taking the AP test right this second. So going a little bit further to simplify, if I multiply by e squared, the reciprocal of 1 over e squared, I have 10e squared over 3e. One of those e's cancels, so we just end up with negative 10e over 3 for the final simplified answer. For the next part of this problem, we're defining h as f of negative 2x, and we want to find h prime of 1. So this is just going to be a big, messy chain rule where we're trying to keep track of things. So let me start with taking the derivative of the outer function. That's f of something. Well, the derivative of that's going to be f prime of something. In this case, f prime of f of negative 2x. Next, I have to take the derivative of the next function in, which is f of negative 2x. Derivative of that is going to be f prime of something, so f prime of negative 2x. And finally, I have to take the derivative of negative 2x itself, and that derivative is just negative 2. All right, so at this point, let me plug 1 into all this stuff. So I'm going to cut and paste all of this. I'm just going to replace all the x's with times 1s. That's all I've done at this point. And now I'm going to start sorting this mess out. So let's see here. I'm going to move this negative 2 out in front just to make it a little easier to look at. And let me also just simplify this a little bit. So I've got f prime of f of negative 2, and then this is going to be f prime of negative 2. Next, I'm going to simplify this f of negative 2 part. In the table, f of negative 2 appears to be negative 3. So this little piece right here, this is going to be f prime of negative 3. I'm just doing this in small pieces so I don't miss anything. And now that I've got just f primes, I'll deal with those. So I've got negative 2 times f prime of negative 3. F prime of negative 3 is negative 1. So this is negative 2 times negative 1 times, well, what's f prime of negative 2? Looking that up in the table, that's going to be a value of 1/3. Okay, so this is just 2 times 1/3, or 2/3. For this last problem part, we're defining yet another function, k, as f of x times arcsine of x over 2, and we want k prime of negative 1. So this time around, we need to use the product rule. That's u prime v plus uv prime. Now let me use the box and ribbon again. I can use it with product rules as well. So I have factors of f of x and arcsine of x over 2. The derivatives of these now, we're going to have f prime of x, and then this is going to be, well, let's see here. This is arcsine of something. This is a chain rule here. So we've got, that's going to be 1 over the square root of 1 minus something squared, so 1 minus x over 2 squared, times the derivative of the something, derivative of x over 2, which is 1/2. All right. At this point, I need to plug negative 1 into all of this, and then I'll put it back together over here. So plugging in negative 1 for x, f of negative 1, in my table here, that's going to be negative 2. And then arcsine of negative 1 over 2, negative 1/2. Well, that's the angle that I have to plug in to get negative 1/2. That would be negative 30, according to the original arcsine function. Which I can also write as negative pi over 6. And that's, we always use radians in calculus, so that's what I'm going with. Now we have f prime of negative 1. That is going to be 6 over 5 from the table. And then finally, this last one's going to take a little work. We have 1 over the square root of 1 minus negative 1 over 2 squared. All right, so let's start in here and work our way out. We have negative 1/2 squared. That's 1/4. 1 minus 1/4 is 3/4. So we have the square root of 3 over 4. The square root of 3 over 4 is square root of 3 divided by 2. And if we flip that, because this is a 1 over, we really have 2 over the square root of 3 times the 1/2 that's already there. Now there's more simplifying to do if you wanted to. These 2's can cancel, leaving us with just 1 over radical 3. And if we were really crazy, we could call this radical 3 over 3, but we'll stop here. All right, so now using the ribbon to multiply these together, I have 6/5 times negative pi over 6. And then going back the other way, I have negative 2 times 1 over radical 3. If you wanted to, you could simplify it a little bit more. These 6's, for example, are going to cancel, leaving us with negative pi over 5. And then over here, we could just call this negative 2 over radical 3.